Welcome to Spot Podcast, the voice of scientists, where groundbreaking research meets your ears. We bring you the world's top cited research articles in an engaging podcast format, making cutting-edge science accessible anytime, anywhere. Stay informed, stay inspired. This is the Spot Podcast, the voice of scientists.
Hey everyone, and welcome back. We're tackling a big one today, something I know a lot of you are really interested in based on what you've been asking about.
Definitely a hot topic.
Exactly. We're diving into the world of clean energy and specifically
Solar hydrogen.
solar hydrogen. Yeah, we talk a lot about wind and solar power and batteries.
Right.
But hydrogen is kind of this up-and-coming contender.
It's definitely got a lot of potential.
It does. And today we're looking at some pretty groundbreaking research.
A paper that details a new system for producing hydrogen fuel using just sunlight and water.
And the scale of this thing is just mind-blowing.
100 square meters?
100 square meters?
Yeah, about the size of a tennis court.
Like a whole tennis court dedicated to making fuel from the sun. I am hooked already, so walk us through this. How does it actually work?
Okay, so picture this. You have a field covered in panels, but not your typical solar panels.
Right. Well.
These are made up of thousands of individual reactor units.
Oh, well.
Each one is like a self-contained system for splitting water into hydrogen and oxygen.
Okay, so instead of generating electricity directly...
They're producing hydrogen fuel.
Clever. Yeah. But how do you split water with sunlight? I mean, isn't that kind of like science fiction?
It might sound that way, but the science is actually pretty straightforward. It all comes down to something called a photocatalyst.
A photo what?
Photocatalyst. It's basically a material that can absorb sunlight and use that energy to trigger a chemical reaction.
I see.
In this case, the reaction is splitting water molecules into hydrogen and oxygen.
So you're saying this photocatalyst is like the magic ingredient?
Exactly. And in the system, they've used a really special kind of photocatalyst.
Oh.
It's a modified form of strontium titanate.
Strontium what now?
Strontium titanate. It's a material that's known to be a good photocatalyst.
Okay.
But they've taken it to the next level by doping it with aluminum.
Doping, like in sports?
Haha, not quite. It just means adding a tiny amount of another element to change its property. And then they coated it with special co-catalysts to make it even more efficient.
So they've really supercharged this material to capture sunlight and split water?
Exactly.
Okay, I'm with you so far. But here's the thing that's bugging me. You split water, you get hydrogen and oxygen. Those are both pretty flammable, right?
You're right to be thinking about safety, especially with hydrogen. But the researchers have been incredibly careful about that.
Oh, good. So how do they keep things from, exploding?
Well, each reactor unit is designed with a very narrow gap between the photocatalyst sheet and the reactor window.
How narrow are we talking?
Like 0.1 millimeters.
Wow, that's tiny.
Yeah, and that gap prevents a dangerous buildup of hydrogen and oxygen gas.
So it's like a constant stream of tiny controlled explosions happening on each panel.
In a way, yeah. But to be extra safe, they actually did some testing where they intentionally ignited the gas mixture.
Wait, they what?
Yeah, of course they took all the necessary safety precautions.
Okay, good.
But they wanted to understand the potential risks and make sure the system could handle any mishaps.
Wow, talk about taking safety seriously.
Right, they're not messing around.
So we've got these panels splitting water, creating tiny bubbles of flammable gas in a controlled environment. What happens next? How do you actually get the hydrogen fuel out?
That's where it gets even more interesting. They use a special kind of membrane to separate the hydrogen from the oxygen.
A membrane, like what kind?
It's a commercial polyimide membrane.
Okay.
You can think of it like a filter that only lets hydrogen pass through.
So it grabs the hydrogen and leaves the oxygen behind. Pretty slick.
It is pretty cool. But separating gases like that does require energy.
And I'm guessing that's one of the challenges they ran into.
You guessed it. Even with optimization, the membrane was only about 73% efficient.
So over a quarter of the hydrogen produced wasn't recovered.
Right. And the energy needed for the separation process was actually more than the energy the system produced.
So there's still some work to be done to make it more efficient.
Definitely. But even with those challenges, this research is a huge step forward.
Yeah. It really shows what's possible when it comes to clean energy.
Absolutely.
Well, this has been fascinating. We've learned about this incredible system that can create clean fuel from sunlight and water.
100 square meters of it.
Yeah. It's mind-blowing.
Yeah.
But it sounds like there's more to the story, right?
Oh, yeah, we've only just scratched the surface.
Okay, well, I'm ready to dive deeper. So, what's next? What else do we need to know about solar hydrogen? So we've just walked through some pretty mind-blowing science. But now I'm curious, why go through all this trouble to produce hydrogen? What makes it so special as a fuel source?
Yeah, that's a question a lot of people ask. You know what's so great about hydrogen?
Exactly.
Well, for one thing, it's incredibly clean. Like, when it burns, the only byproduct is water.
Okay, so no nasty emissions, no greenhouse gases.
Exactly. It's the ultimate clean fuel.
That's a huge plus. But isn't hydrogen also, like, really flammable? I mean, I remember learning about the Hindenburg disaster.
Yeah, that's a common concern. And you're right, hydrogen is flammable.
Okay.
But, so are gasoline and natural gas. The fuels we use every day. The key is safe handling and storage.
Right.
Which, as we've seen, these researchers have taken very seriously.
Yeah, they even intentionally ignited the gas mixture in their tests.
Exactly. So with the right precautions, it can be used safely.
Okay, that makes me feel better. So it's clean burning, and with the right precautions, it can be handled safely. What else makes hydrogen such a promising fuel source?
Well, besides its cleanliness, hydrogen is incredibly versatile.
Oh, how so?
Well, for one thing, we can use it in fuel cells to generate electricity.
Okay.
Which can power anything from our homes to our cars.
So you're saying it's not just for, like, rockets and stuff?
Nope, not at all.
Yeah.
And did you know we can even blend hydrogen with natural gas in existing pipelines?
Oh, wow. So we could actually start using it without, like, a complete overhaul of our energy infrastructure.
Exactly. And that's not all. We can also use hydrogen in industrial processes, like producing ammonia for fertilizers or even in steel production.
Wow, I had no idea. So it's clean, versatile, and it has the potential to replace fossil fuels in a lot of different applications.
Exactly.
But with all the challenges we talk about, like efficiency and the energy needed for separation, is it really a practical solution for the future?
That's a fair question. And it's important to remember that this technology is still in its early stages.
Okay.
Think about solar panels. Back in the day, they were bulky, inefficient, and super expensive.
Yeah, that's true.
But through research and innovation, they've become much more efficient, affordable, and accessible.
Right.
We can imagine a similar trajectory for solar hydrogen production.
So you're saying we need to be patient and give it time to develop?
Exactly. The fact that researchers were able to build and operate a 100-square-meter system is a huge accomplishment.
Yeah, that's pretty amazing.
As research continues, we can expect to see big improvements in efficiency cost and those energy-intensive separation processes.
Makes sense. So let's say for a moment that those challenges are overcome. What would a future powered by solar hydrogen look like? What are some of the possibilities?
Well, one area I'm really excited about is localized energy production.
Oh, interesting. What do you mean by that?
Well, imagine if you could install a solar hydrogen system on your roof.
Like solar panels, but for hydrogen.
Exactly. You could generate your own clean, fuel-store excess energy for later use and even potentially sell it back to the grid.
Wow. So like a truly self-sufficient energy system.
Exactly. And it's not just for individual homes. Think about developing countries where access to reliable electricity is often limited.
Right.
Solar hydrogen systems could provide a clean, affordable, and sustainable solution for powering homes, businesses, even entire villages.
That's a game changer for sure.
And speaking of game changers, let's not forget transportation. Imagine airplanes, ships, long-haul trucks, all running on hydrogen fuel cells.
It's hard to picture a jumbo jet running on batteries.
Yeah, but hydrogen could make that possible.
So we could have truly sustainable air travel.
Exactly. As the technology advances and costs come down, we could see a massive shift towards hydrogen-powered transportation.
This is all very exciting, but are there any downsides to this technology that we should be aware of? Any potential risks or unintended consequences?
You bring up an important point. It's always crucial to consider the full picture. And like any new technology, there are potential downsides to solar hydrogen production.
Okay, like what?
Well, one concern is the use of water as a feedstock.
Water. But isn't water abundant?
It is in many parts of the world. But many regions also face water scarcity.
Right.
Diverting large amounts of water for hydrogen production could make those problems worse. So we need to be mindful of where and how we implement this technology.
That's a good point. We don't want to solve one problem by creating another.
Exactly. And another consideration is the potential for leaks. Hydrogen is the smallest molecule, and it can be tricky to contain.
So leaks could be a problem.
There could be leaks in production storage, or transportation systems could release hydrogen into the atmosphere.
Wouldn't that be bad for the environment?
Well, hydrogen itself isn't a direct greenhouse gas, but it can indirectly contribute to warming.
I see. So we need to make sure the entire hydrogen infrastructure is top-notch to prevent leaks.
Exactly. And finally, we have to be aware of the potential for unintended consequences as we transition to a hydrogen economy.
Like what?
Well, any major shift in energy systems will inevitably create winners and losers.
Right.
Some industries will thrive while others may struggle to adapt.
So we need to make sure the transition is fair and equitable.
Exactly. We need to think about job creation, economic impacts, and social equity as we build out this new energy infrastructure. It's crucial to have these conversations now so we can create a more sustainable and equitable future for everyone.
That's a great point. Technology alone isn't enough. We need to consider the human element, the social and economic impacts of these innovations. Okay, well, before we get too far ahead of ourselves, let's take a moment to recap what we've learned about this research. We started by exploring the technical details of this amazing 100-square-meter solar hydrogen production system. And we talked about how they use a special membrane to separate the hydrogen fuel from the oxygen.
Right, and we talked about why hydrogen is so promising as a clean, versatile fuel source. Something that could really change the game for everything from transportation to heavy industry.
We even got into some of the hurdles that still need to be cleared, like boosting efficiency, getting the costs down, and figuring out how to make that separation process less energy intensive.
And of course, we can't forget the bigger picture, like needing a solid infrastructure for hydrogen production, storage, and distribution. Not to mention those potential impacts on water resources and making sure we prevent leaks.
But even with those challenges, we found some pretty inspiring possibilities, like localized energy production, giving people and communities the power to create their own clean fuel, and even the idea of decarbonizing industries that rely so heavily on fossil fuels right now.
It's been a wild ride, hasn't it? Exploring all the technical wonders and the bigger implications of this research.
It really is. It blows my mind that something as basic as sunlight and water could be the key to a cleaner, more sustainable future.
It really speaks to the power of human ingenuity and how important it is to keep investing in research and development, pushing the boundaries of what we think is possible.
As we wrap up this deep dive, we want to leave you with something to think about. We've seen how innovation can lead to progress, but it's so important to approach these advancements with a sense of responsibility, making sure these technologies benefit everyone.
So as you go about your day, ask yourself, what role will you play in shaping this future? What can you do, big or small, to contribute to a world where clean energy is available to everyone?
Thanks for joining us on this journey into the amazing world of solar hydrogen. We hope you've enjoyed it as much as we have. Until next time, keep learning, keep asking those tough questions, and keep diving deep.
Stay curious, keep exploring, and join us next time for more groundbreaking research brought straight to your ears. Don't forget to subscribe and share, because science is meant to be heard.